Okay, the second video for today is we're going to check your homework. So you had to answer two set of questions. The first one was in your document in Google Classroom that is called Matter and Mixtures Theory. You were going to answer the questions to states of matter which were on page 3. So for question 1, let me just check. I have it here to read the question. The question 1 says, what are the two forces that affect how close particles are to each other? So the two forces are first electrostatic force and the second one is heat. Okay, I want you to write in your book. Let me just do something here. I want you to write in your book this because I want you to have the full answer. I don't want you to have only to state it, but I also want to write notes of what each one of these forces do to those particles. So the first one is trying to make particles closer together. Remember when we did forces on our last topic, the girls that did electrostatic force explained how objects that are charged with a negative charge will be attracted to a positive objects with a positive charge. And the example that they gave, for example, is when you have a balloon and you rub it and it gets negative charge, it will pull your hair up. So this is the force that is keeping particles close together. And heat will do the opposite. It's going to try to make the particles move apart. Okay, the second question is why can air be compressed but metals cannot? So air can be compressed because there is plenty of space between particles, so they can be compressed together. Whereas solids, particles don't have enough space. They don't have any space. They're very tight together, so you cannot compress them. Question 3 and question 4 was about filling this table. I want you to copy this table, girls, into your notebooks because I want you to draw the images so that you have all the information in your notebook. So the first one is a fluid, which is a state that the particles are close together, but the particles are vibrating. In this state, the particles can slide past each other and create a flow. So if you see here, the particles are vibrating. You can see here what they were trying to draw. They're close together, but they're not fixed together. I'm going to jump to the bottom one. How do I know that this one is a solid and this one is the liquid? If you can see here in this drawing, they allow you to see that there is a space in the container around it. So I know that this shape here is holding its shape within the container, whereas here the particles have moved to take the shape of the container. So I know that this one is the liquid. The second one is much more clear with the diagram because I know that it's a gas because there is plenty of space and they're moving everywhere. So this is a little bit more clear, this diagram. So gas is the state the particles are far apart. The particles are moving quickly in all directions. The electrostatic force of attractions are not even noticeable because the particles have too much energy. And in the solid, this state of particles are close together. The particles are vibrating. In this state, the particles are held together by strong electrostatic forces of attraction. In this state, the particles cannot be compressed and cannot slide past each other to create a flow. Okay, question 5. Question 5 is the one that is saying, why can we jump through water, but if we try and jump through concrete, we go splat? So the answer is D, is for all the options that they have here. So I have put it here in order, and I want you to copy this into your notebook. So the first part is because the particles in concrete are held together, because it's a solid, right? In a lattice, that means next to each other. But water particles can slide past each other and can be pushed away, okay? So that's the first reason. So it's about the characteristics that concrete and water have because of the states of matter. The second reason is because of the force of our bodies is strong enough to push the water particles to either side. So our body has the strength to push the particles of the water to each side. The third reason is because the force of our bodies is not strong enough to push the particles which make up concrete aside, okay? For question 6, it says, true or false, we can cut an apple in half because the knife is strong enough to push the apple particles away from each other. So the answer is true in a similar way of what I just explained. We can cut an apple with a knife because the properties of the knife is that it's strong enough that it can push the particles of the apple away. Okay? Okay, last question 7. Describe an experiment you can do to show that gases have mass. So I will be interested to find out which experiments you thought about, but I thought about this one and I just thought that I can share it with you. So if I have two basketball balls, one is inflated, so which with air, right? We inflate basketball balls with air, and the other one is deflated, okay? And let's say that I have a student in front of me. Let's say that I have Isha, just to select one of my students. So if I have Isha in front of me and I throw the basketball ball to Isha, first the deflated one. So I throw it as hard as I can, but Isha is not going to feel almost any force, agree? Because the ball is deflated. But what will happen if I do the same thing with the inflated ball and I throw it as hard as I can? Sorry, Isha. She will feel a punch, agree? She will feel the force. What is the difference between the two balls? The difference between the two balls is the air that it has. So the difference is the matter that it has, because air does have matter. So the matter is what is giving that punch, that force that each will feel with the inflated ball. I hope you see this clearly, and I'll be happy to answer any questions next class.